The next unit is going to have a lot to do with exponents and what we call monomials and polynomials. Tonight's homework is actually yet another night of review, but I'm going to go through some of the basics involved. I think that everyone is probably aware that 3, for example, 3 to the third power means 3 times 3 times 3, where the number 3 is the base, and the number, oh, I should have used a different number. Let's use a different number. Let's say it's 4. 3 to the fourth power means 3 times 3 times 3 times 3, where 3 here is the base, and this number is the exponent. It tells us how many times we are multiplying something together. If I say the number x times x times x times x, we don't know what the number x is, what that variable is representing, but regardless of that, we know that it equals x to the fourth power. This is a lot of what we're going to be doing in this unit, is finding out what would be true in a given expression or operation, no matter what we plug in for the value of the variable. So just try to keep that in mind. This, when we use an exponent to write it, is called exponential form. And this is called expanded form. What Mr. Walsh used to like to refer to as opening the accordion. So really that's pretty straightforward. We want to make sure that you understand. If I say 4x to the fifth, I don't know, y to the second, when I expand that, this, by the way, this number 4 is called the coefficient. We're going to be dealing with that a lot. It is 4 times x times x times x times x times x times y times y. This is exponential form. This is expanded form. Now, if I say to you xy squared, that means that the x and the y together are being raised to the second power. So that means xy times xy times xy, which is different than xy squared, which is x times y, and is different still from x plus y squared, which is x plus y times x plus y. In each case, you really have to look at what the exponent is referring to. These parentheses in this problem mean that it is this entire quantity that is being raised to the second power. So it will be xy times, oops, glad I was going back over. It's just to the second power. Clearly I make mistakes. So xy squared just means xy times xy. Xy squared, when there are no parentheses, means that just the y is being raised to the second power. So if I open that accordion, it's x times y times y. And similarly, if I open this accordion, the whole thing that's in parentheses is what is being raised to the power. So this, you would say this is 4x to the fifth y to the second. The exponents here would be called the fifth power. This is the second power, otherwise known as squared. If I talk about something to the third power, it is in expanded form x times x times x, and it's otherwise known as x cubed, which comes from the solid cube has a volume of x to the third power if it has a side length of x. The harder part of tonight's homework is showing replacement and following Gremdas. But once again, this is nothing that is completely new to us. I'm going to do the 2 examples that are in the book where you are to evaluate the problem 2a plus b squared if A is equal to 3 and B is equal to 2. When I say in your homework that you need to show replacement, I mean the first thing before you do in any math, I want you to show that you are plugging in the value of 3 for A and the value of 2 for B. If you do that, you're far less likely to make mistakes when following GREMDAS. Here we have GR, grouping symbols, so I need to do what's inside of this. And within the grouping symbols, I follow GREMDAS, which means I'm going to do this multiplication before I do the addition. I'll finish what's in the grouping symbols. I've got 8, and 8 squared is 64. Actually, I just noticed that in the problem, they say, in the book, they say A is 3 and B is -2. So let's do that problem too, because negatives always make things more interesting. I'm still going to show replacement, and it's going to be 2 times 3, but this time I'm going to be adding -2 and then squaring that. 2 times 3 is still 6, but plus -2 equals 4, and 4 squared is 16. The next problem brings in more of the complicated things, where you have to really think about exactly what's being raised to a power. Actually, I don't really like that example. I'm going to do a different one. I'm going to say the problem 3x y to the third divided by the quantity of 2x squared for x equals 1 and y equals -2. So showing replacement, I will say 3 times 1 times -2 to the third power divided by the quantity of 2 times 1 to the second power. So I need to attend to my exponents first. So 3 times 1 is obviously 3. I'm going to ignore that 1. 3 times -2 to the third power. As we've seen, a negative number raised to an odd power is negative. That goes back to your first test. And on the bottom, we're going to have 2 times 1 is 2. So this is 2 squared is 4. Actually, let's write it down here. 2 squared. So that gives me -24 divided by 4. And when I have a negative number divided by a positive, it is negative. So the answer is -6. We'll be going into much more detail all about exponents and expressions, but that pretty much is what you need to know for tonight.